Graphing inverse trigonometric functions. If we look at the sine curve below, we can see the domain for this is infinite. So here we continue to negative infinity, here we continue to infinity. And we see our range is between 1 and -1. So our range is restricted here between -1 and 1. We also see our sine curve has a period of 2 pi where it repeats. Cosine function is similar. So again, here, our domain will continue negative infinity to infinity, and our range between 1 and -1 here. Again, we have a period here of 2 pi where our curve repeats. And we see our tangent function, however, is different. So we see in our domain, we have our asymptotes. So our x is not equal to pi on 2, negative pi on 2, 3 pi on 2, negative 3 pi on 2, and so on. And we see that our range continues here and here to infinity and negative infinity. So if we look at these functions, we can see that they fail the horizontal line test to have inverse functions. Here our tan function, we cut through many of these curves here. Our sine function here, we cut through many times. And our cosine function here, we also cut through many times here. So here we've noticed that they fail this horizontal line test to have inverse functions. So to work around this, or work with this, we restrict the domain of the trigonometric functions. So looking at our sine curve, if we restrict our domain from negative pi on 2 to positive pi on 2, as we've shown below, we can see this meets our requirements to have an inverse relation. So we won't cut through more than one time. So our range is from 1 to -1 here, -1 and +1, sorry, and our domain here, negative pi on 2 to pi on 2. Similarly with our cosine curve, if we restrict our domain 0 to pi here, we see that this meets our requirements. We can put horizontal lines through without cutting through twice. Our range again is 1 to -1 here. And with our tangent function here, so we restrict our domain from negative pi on 2 to pi on 2. We can see that this meets our requirements to have an inverse relation. Here we continue on, so our range will be from infinity to negative infinity here. So looking at each of these functions, we want to consider the reflections of the curves about our line y is equal to x. So this is shown in black on each of our sketches here. So our original curves are shown here in the blue. So here is our original sine curve, our original cosine curve, and our original tangent curve here. And in red, we show the inverse of each of our functions here. So here, our inverse, there, our inverse, and our inverse here. So what we see with this here, our inverse of the sine function, we write this as here inverse of sine, y is equal to inverse of sine of x. Our domain is between -1 and 1. So here our domain is between 1 and -1 here. And this is the same as what our range was for our sine function. So this is equal to our sine of x range. And our range here for our inverse of the sine function is between negative pi on 2, negative pi on 2 and pi on 2. So here it's equal to the domain for sine of x. Same for our inverse of the cosine function here. So our domain is between 1 and -1 here, 1 and -1, which was what our range was on our cosine function. And our range is between 0 and pi. Here, 0 and pi, which was what our domain was on our cosine function. For our inverse tan function, our domain here, so we continue on here, is -infinity to +infinity. And with here, our original tangent function, that was our range. And our range for our inverse function is here. We've got -pi on 2 to pi on 2, which is what our domain was for our original tangent function. Similarly for our cot function, coset function, and our sec function. So again, we restrict our domains and we show how our inverse functions move about our line y is equal to x here.